Knock, knock, knock.
Hello.
Hey, Dr. Doug, it's Chase from Respiratory Therapy. I'm here to do a couple basic pulmonary function tests with you. I'm going to explain the tests to you. I'm going to explain to you what normal values and critical values are, and then I'm going to have you perform that test. The first test I need to explain to you is a peak expiratory flow rate. I do this test with a peak expiratory flow meter. This test measures how fast you can blow the gas out. Normals for peak expiratory flow rates. One author says for an adult, any adult should be able to exhale faster than 500 liters per second. In reality, it's best to look at the normals, which is based upon your gender, your age, and your height. So I see, based upon your age, gender, and height, that you should be able to exhale at least 600 liters per second out of this device. Now, when you blow through this device, I'm going to have you do it 3 times and make sure those 3 values are pretty close to each other, within 10%. If you blow greater than 80% of your predicted values on the normogram, you're considered normal. If you're less than 50% of your predicted values, we would consider that a critical value. So, what I'm going to do is take this disposable tube. I'm going to put it on relatively forcefully around here. I'm going to set these 3 indicators based upon that normal. Dr. Doug's normal that I looked up was 600, so I'm going to set this first one so that the green zone is 80% of 600. I'm going to set the red zone at 300, which would mean that anything below 300 was critical. And I'm going to set this yellow zone between the first 2 zones. Okay? If you can stand up for me, Dr. Doug. What I want you to do is turn towards the camera. There you go. Hold this in both hands. Don't put your fingers over the back of this. I'm going to reset the indicator to the bottom. Take a nice deep breath. Put your lips around the outside of that mouthpiece and blow as hard and as fast as you can through the device, like you're blowing out candles. Good. The first measurement was 640. Can you do that again for me? Good. The second measurement was also 640. Can you do that a 3rd time for me? And the 3rd measurement was 630. So I have 3 measurements within 10% of each other. I know that you're giving me your best effort. Okay? Go ahead and sit back down for me. So Dr. Doug could exhale the gas at 640 liters per minute. His predicted was 600, therefore he's above predicted, which would mean he's perfectly normal. If Dr. Doug had an obstructive disease, when he tried to blow the gas out fast, that gas would obstruct and he would not be able to blow out that fast. That was a peak expiratory flow rate by a peak expiratory flow meter. The next test that we're going to go over is a vital capacity. The vital capacity is going to be measured by a respirometer. Okay? To perform the vital capacity, I'm going to make sure that he has a filter, and the filter is going to interface with the respirometer. The respirometer, most of them have 3 buttons. One button will turn on and off the device. Okay? The other button resets the device. So as you blow into the side, it comes out the bottom. It doesn't work the opposite way. You don't blow in the bottom to have it come out the side. So to test it, I will take a breath. And I see that it does move around. And now I will realize that this is my reset button. His filter is going to fit on this way. I'm going to take these and use them as nose clips so that he can only breathe through his mouth. Dr. Doug, the next thing I need to do with you is I need to measure how much volume you can move in one breath. Normally, this amount of volume is based upon how tall we are and our gender. I'll give you that equation in class at a later semester. Right now, you need to know that you normally could move 65 to 75 milliliters per how tall you are. A critical value would be if he moved less than 10 milliliters per how tall he is. So what I want you to do, Dr. Doug, is go ahead and stand up for me. I'm going to take these nose clips, I'm going to put them over top of your nose. They feel nice and comfortable. I'm going to reset this to 0. Take a nice deep breath, as much as you can in your mouth, more. Put your mouth around there and blow it out nice and slow. Keep blowing, keep blowing, keep blowing. Push until you're all empty. Push. Good, and stop. Okay, you can take that out for a second. I can now read this, and I see that Dr. Doug has blown 4.25 liters. So he moved 4.25 liters. And I would expect him to be able to replicate that 2 more times. For the purpose of this video, I'm not going to do that. Okay? So that was a vital capacity, how much air he could move in one breath. If this measures a volume. He exhaled 4.25 liters. I would need to calculate what his normal is and what his critical value is. But I'm telling you that that value of 4.25 liters is probably above, or is above, his normal. Okay? The second test I need to do with this is a minute ventilation. So I'm going to reset this to start at 0. I'm going to apply the nose clips back to Dr. Doug. And what a minute ventilation is the amount of volume that he is going to breathe in 1 full minute. So I'm going to have him breathe normally through this device and count his respirations for a full minute. That will give me the amount of volume in that minute, but I will also have the number of respirations or number of breaths that he's had in that minute. Okay? For the purposes of the video, I'll probably shorten that time. Dr. Doug, go ahead and put those on for me. What I need you to do is put your lips around your mouthpiece and just breathe normally through this device for a full minute. So I'm going to look at my watch, and I'll let you know when to start, and start now. That's 1 breath. 2. 3. 4. 5. And I continue this process for a full minute, and I find out after a full minute he has 12 breaths. You can stop now, Dr. Doug. I've counted 12 breaths, and I look at my volume, and I see that my volume is 12 liters perfectly. So now I can say, all right, my minute ventilation was 12 liters per minute. His respiratory rate was also 12 breaths per minute. Therefore, the amount of volume per breath, 12 liters in a minute, divided by 12 breaths, told me that every breath was 1 liter. So his tidal volume was 1 liter, which is the amount of volume per breath. Normally, my minute ventilation is somewhere between 5 to 7 liters. His was 12 liters per minute. So that would tell me that he's moving more volume than a normal adult. My normal respiratory rate is 12 to 20. His respiratory rate was 12. So that would tell me that his respirations were normal. His tidal volume was 1 liter. His normal tidal volume is based upon his height once again, so I would have to calculate it. But I can tell you that his tidal volume is more than what I would expect based upon his height. So he was breathing deeply, even though his respiratory rate was the same. Since he had hyperpnea, his minute ventilation was elevated. Critical values for these numbers: a minute ventilation above 10 liters per minute. I wouldn't expect a person to be able to keep that up for a long period of time. They probably will fail, right? If I had a minute ventilation of 10, I wouldn't be able to keep that up. So I would expect that that person would not do well. That is a critical value. A respiratory rate of less than 6 or a respiratory rate of above 25 would be a critical value. I wouldn't expect them to be able to keep that up. A tidal volume that is really low, less than 5 milliliters per kilo, ideal body weight, is also considered a critical value. That's the third test that we've done. It was the second device. This device measures volume. We used it for a vital capacity and a minute ventilation. The last device that we use is a NIF meter, a negative inspiratory force meter. The NIF meter is going to use the NIF meter measures negative pressure. It measures force. It tells me how strong the respiratory muscles are when I'm trying to inhale. It's got a resettable gauge that you should reset at 0 every time, just like the peak flow meter. A short piece of tube is going to be applied to the bottom of the NIF meter, with the other side hooking up to the series of one-way adapters. So these one-way adapters will only allow Dr. Doug to exhale or to exhale once I occlude one side. So take a look at it and figure out which side to put the thumb adapter so that only the person can only exhale once I occlude the thumb adapter, and I realize it's on that side. I now will put the tubing on the adapter here so that I can measure the negative pressure inside of my adapter, which will tell me the negative pressure being generated by his diaphragm. His filter now interfaces on this side so that it looks like that once it's all set. As he inhales and exhales out here, I'll watch the one-way valves work to make sure I know what's going to happen when I occlude this hole. Okay, so this test tells me how strong his diaphragm is, whereas the other two tests, I have to rely on the patient to give me their best effort. If a patient had a tube in and the only way they could breathe was through the tube, I guarantee I'll get the best effort from him, because the only way that he's going to be able to breathe is through this device. Normally, you and I should be able to generate a lot of negative pressure with our diaphragm and other muscles. So a normal value is less negative than negative 60, meaning negative 61, negative 65, negative 120. A critical value would be a value less negative than negative 20, meaning negative 19, negative 10, negative 5. That would mean the person can't pull that very well to inhale the gas. So what I want to do, Dr. Doug, is I'm going to put your lips around the outside of this mouthpiece. You're going to breathe normally for a second. When I see you fully exhale, I'm going to plug the port. You won't be able to breathe, but relax. Just give me the best effort that you can. I'm going to hold this until one of three things happen. One, Dr. Doug gives me a negative value, more negative than what a normal person could do. For example, if on his first attempt he pulls negative 70, there's no reason to continue the test. He has shown me that he is really strong. If Dr. Doug has pulled and he has been trying to inhale for greater than 30 seconds, and I see that he's only doing negative 30, negative 30, negative 30, so he's maxed out his ability, and that time has been more than 30 seconds, I will stop the test, because that's all that he can do. Finally, if I see that Dr. Doug is starting to exhibit signs that are telling me that he's not tolerating this, he's starting to pass out, his heart rate's going up, his respiratory rate is, well, his respiratory rate's going to be going up anyways, his saturation is going down, he doesn't look good, I will stop the test. They're the three reasons why you stop the test. All right, Dr. Doug, what I'm going to do is I'm going to put these on your nose again. Go ahead and put your lips around the outside of this and just breathe normally for me. And I notice every time he inhales, the gas is going in here, and every time he exhales, the gas is coming out here. So I know when I plug this up, it's going to make it so that he can only exhale. All right, Dr. Doug, it's going to feel like you can't breathe. Just go ahead and take a breath and try to take a deep breath. Okay? There's negative 40, There's negative 50. There's negative 60. There's negative 100. Good. And just breathe normally for me. Okay? So he can generate a negative pressure that is more than what I would expect for a normal person. So I stopped the test. If he didn't generate negative 60, I would continue the test for at least 30 seconds until I saw that he was generating as much on repeated attempts, and I knew that that's all that he could do. Finally, if he started to turn bright red or bright blue, start acting like he was going to pass out, or if his vital signs started to be really bad, then I would obviously stop the test. Thank you.